13.5, day 1 notes. We are going to be graphing the cosine function. So go ahead and jot down everything you see here. This is the unit circle again, the 4 main points. And what's interesting, so we did this with sine. And now we're going to repeat the process with cosine. Can anybody remind us? We just spent 3 periods on the sine curve. Where did sine always start? 0, 0, okay? So what we're going to find out with cosine is it has a different starting point. So when you look at your unit circle, you have your 4 main points. 1, 0, 0, 1, negative 1, 0, 0, negative 1. And remember, every x comma y goes cosine theta, comma, sine theta. So what we're going to graph this time is cosine theta. So just like we did with sine, we're going to go around 0 degrees, 90 degrees, 180, 270, 360, and we're going to look at the x coordinates. So the good news is if you ever forget where sine starts or where cosine starts, you make a unit circle and you've got to remember cosine is 1, sine is 0, okay? So when I did this, I got 1, 0, negative 1, 0, 1. The period length for cosine is also 360 degrees. The amplitude is 1. Now this is for cosine x or cosine theta. The domain is negative infinity to infinity, and the range oscillates between negative 1 and 1. So I made a coordinate grid, and I made 4 ticks to the right and called it the period length, 360 degrees. And I did 4 to the left, called it negative 360 degrees. Make sure when you are asked to sketch a graph, you are labeling the x and y axis. You've got to let me know what your tick marks represent, because it varies from problem to problem. So I plotted then 0, 1, and what we're going to learn in general about cosine is it starts at the a value. Okay, it's always going to start at your a value. So if a is positive, you go up. If a is negative, you go down. Then it was 90 degrees, comma 0, 180, negative 1, 270, 0, 361. And then you just follow the pattern. So this is so similar to the sine curve. The sine curve started at 0, 0. Cosine starts on the y-axis at the a value. That's the big difference. But then it's going to follow the pattern. It really does. And where is it coming from? It's coming from the unit circle. All right, everybody got it? All right, so we're going to do a few practice graphs and I think writing one equation. So let's go. Number 1. Graph y equals 3 cosine x. So the period length is 360. It is still going to be 360 divided by the b value. My amplitude is the absolute value of a, and you might want to just write a, because what you do to graph, you start at a. Okay, you're going to start at A. I'll explain what that means as I do this graph. So let's make a coordinate grid. We're going to do 4 ticks to the right and call it the period length. So that's 360. And we'll make the second tick 180. I'm going to go up and down to the A value. So how do I know how to graph this? Let's go back to the previous slide real quickly. My table is A, 0, opposite A, 0, A. It's always going to rotate like that. So I'm going to start at 3, 0, negative 3, 0, 3. The only time you need to do 2 graphs, a dashed and a solid, or 2 different colors, is when you do the left, right, up, down. I don't have any left, right, up, down, so this is one graph. You follow the pattern to the left. And because cosine is periodic as well as sine, do you see the start and stop is the same height? If it's not, you've done something wrong. You see that? On the far left, I'm up at 3. I complete 1 cycle. I complete a second cycle, and I have to end at where y is 3. Let's talk domain and range. Domain is negative infinity to infinity. Anybody want to try the range? Grace. Good job. Negative 3 to 3. All right, so this is not too bad. And I thought it would go a little bit faster now that we understand sine curve. Cosine just has a different starting spot. That's it. All right, let's try this one. Example 2. You want to graph y equals negative 2 cosine x. So the period length is 360 because there's nothing in front of x. My amplitude is positive 2, but my A value is negative 2. So that's going to make a difference, okay? That will make a difference. So let's make a coordinate grid. Make 4 ticks to the right and call it the period length. It's not always 360, but the first few are. And I'm going to go up 2, down 2. So where is this one going to start? Awesome. Okay, this is going to start down at negative 2, then it goes 0, up 2, 0, down 2. And then you just follow the pattern. When you're done, you should really think about, did I start and stop at the same place? And I did. My domain is negative infinity to infinity. Kat, you want to try the range on this one? Good. Negative 2 to 2. The range are the y values. We are sketching just 2 period lengths. 1 period to the left, 1 period to the right. A period is a cycle. Like how long does it take before it's going to repeat? All right, any questions on this? Again, if I get going too quickly, you can watch the video and fill in what you need. Ooh, okay, finally, we're going to get something where the period length changes. refresh our memories, the period length is 360 divided by b, and b is 2 in this case. So my period length is 180. What's the amplitude? Awesome. It's 1 and a is 1. Okay. Amplitude, and let's make sure we're catching this. Y equals a cosine bx. Okay. So a, absolute value of a is amplitude. Period is 360 divided by the b value. So I'm going to make 4 ticks to the right and call it 180 degrees. Now I don't intend to mislead you. Is graphing cosine 2x and graphing cosine x looks like the same curve based on how we're doing this, but you understand that actually I would have twice as many in here. From 0 to 180 is a complete cycle, so if I did 360, there would be 2 of them there as the parent function. So it really is twice as many. So this one's going to start at 1, 0, negative 1, 0, 1. Make it nice and rounded and curved. It's not like pointy. It's not B's. So my domain is negative infinity to infinity. The range is negative 1 to 1. This one. What if I ask you to graph y equals cosine x over 3? We've seen this one before. And if you notice, what I have below is I rewrote it, because when I say the period length is 360 divided by b, b has to be in front of x. If there's something underneath x, I've got to rewrite it. So I have rewritten this as cosine 1/3 x. So the period length is 360 divided by 1/3. Well, when you divide by a fraction, that's the same as multiplying by the reciprocal. So that's 1,080 degrees. This is like really stretched out. My amplitude is 1 and A is 1. So that's 540 would be my second tick. So I start at 1, 0, negative 1, 0, 1. So even though this looks a lot like the last one, it really isn't. 180, how many times would 180 go into 1,080? I'm going to grab my calculator and figure that out. I got 6 times, so like I would get 6 of the cosine 2x's just in one period length here. Does that make sense? Like, so even though the way that we're doing this, it makes it look like they're the same, they are actually very far from the same. So the domain is still negative infinity to infinity, and the range is negative 1 to 1. All right, now let's put 2 of them together where we mess with the amplitude and the period length. Here we go. Example 5. We want to graph y equals negative 3 cosine 4x. So what I want you to do is I want you to determine the period length, the amplitude, and A. See if you can get that much on your own. So the period length is 360 divided by 4, so what's the period length? 90. And what's my amplitude? Positive 3, but the A value is negative 3. Okay, amplitude is always positive. So we're going to make 4 ticks to the right and call it 90 degrees. And I'm going to go up 3, down 3. Make sure, again, on the x-axis and y-axis, you are labeling because the period length varies from problem to problem. So you can't assume that the tick marks are the same. All right, now where is this one going to start? Negative 3, nice. Okay, so this is going to start down at negative 3, 0, 3, 0, negative 3. And you can think of it as a reflection over the x-axis. Normally it starts at 3 and it's been reflected. And look at my start, stop. It is the same. So the domain, that's a parenthesis. Negative infinity to infinity, and my range is negative 3 to 3. All right, one last graph where we put the two together, and we'll do one writing equation after this. Everybody good? All right, try this one. Let me give you a head start and see how far you can get. So what's the period length on this one? 720, because you take 360 divided by 1/2. When you divide by a fraction, you change it to multiply by the reciprocal. Alright, so I'm going to start at 1/2. So this one's like a little shrink. It's not oscillating very much. So the domain is negative infinity to infinity. The range is negative 1/2 to 1/2. Does this seem a whole lot smoother now that we've spent 3 class periods on the sine curve? I think cosine, it just flows a lot better. Good. All right, we're going to do one last one, and we're just going to write the equation. All right, write the equation of a cosine curve, cosine function with amplitude 6 and period equal to 90 degrees. my A value is 6. The only way A turns negative is if it says there's a reflection, or you have the graph that shows A is down at the negative. To get the period length, it's 360 divided by B, and I think we can do that one in our head. 360 divided by what is 90, that's 4. So you're plugging into y equals cosine bx. So y equals 6 cosine 4x. All right, any questions on that? All right.